Okay, folks, let's find the domain of a composition of two functions. Let's begin with this function f here, 3 over x minus 1, and then we've got g, which is 5x over x plus 3. Now, I'm asking you to find the domain of f of g of x. So, this statement says what? That the x's in red will first be placed into the function g, and you will get a number, which is a g value. And then that g value is going to be inserted into the function in black. Okay, so that number in red is then going to try to go into the function in black, and when it does, we need a real output. Yeah? Okay, so we need the x's that will take us what? Into g. A real number will be produced, and then that g value will also fall into the domain of f, and then that g value will produce a real output for f. Okay? Now, there are numbers here that, let's call them x's here in red, that when you try to plug them into g, you immediately get stopped. Okay? So there are x values that don't even get you into g. And so if you're an x value that does not lie in the domain of g, then it clearly cannot be in the domain of the composition. All right? Now, those are the kinds of numbers that we're going to be looking for. We're also going to look for x values here in red that will lie in the domain of g. They will produce a real g value, but then they do not allow you to get into f. Okay? So once we figure out what these kinds of numbers are, that'll, by deduction, leave us with all the numbers that we can plug in to this composition. Okay? So, let's begin. Are there any numbers that won't even get you into g? Well, let's look at g. Is there an x here in red that you cannot plug in? And the answer is what? -3, correct? So, if you plug in -3 into the red function, you're going to get an undefined output. So -3 does not lie in the domain of g, therefore it does not lie in the domain of the composition. So far we're saying that x cannot be -3, right? Okay, now, let's look for these numbers, okay? X's that produce g values that don't get into f. Well, how is it possible that a g value does not get into f? Well, let's look at f. F takes inputs into it, and it puts that input into the denominator, and then it subtracts 1. But by the diagram, we need to remember that we're not plugging in directly x values, but we're plugging in the g's. So, we see that a g value of 1, okay, a g value of 1 would not get you into f, because a g value of 1 would make that denominator 0. Okay, so let's figure out, how is it possible that the function g of x minus 1 will be 0? Okay, so g is equal to 1. How? Well, that would be when this fraction here in red, 5x over x plus 3, is equal to 1. Okay, so now if we solve this equation, that'll actually tell us the x value back here that produced the g value of 1, which then did not go into f. Okay, so we multiply both sides of this equation by x plus 3. Okay, I'm going to assume everyone can solve a rational function. Excuse me, a rational equation. And then subtract x from both sides. And you see that x, which is 3/4, is the one that will do it. Okay? So if x, let's read the work now going backwards. If x is 3/4 all the way back here in red, it will then produce a g value of 1, right? That's what that says. And then that g value of 1 will get plugged into the black function f, and it will make this denominator equal to 0. Okay? And then f would become undefined. So, we have found the two trouble numbers, if you want to call them that. And so our domain is going to be all these other numbers. So the domain for the composition will be all real numbers except for -3 and 3/4. Okay? All right, let's try another example. Let me just take a moment to erase all this. All right, so what do we have next? We've got f, which is 3x plus 1. And then we'll use a g value, which is 3 over x plus 1. Okay? And so, again, let's find the domain for the composition of the red function g being placed into the function f in black. So the diagram would mean what? That the x's are in red, and we're going to plug them into the first function, which is g, in red. Okay, so the x's go into g, and then those g values in red will go into the second function, f, in black. Okay? So we would love to have a real number x produce a real value g, and that g is a real number that falls into the domain of f, and it makes f produce a real output. Okay? So, what did we say a moment ago? We're going to first try to find the x's that don't even get us into g. Are there any numbers that do that? You tell me. Look at g. That's right. It would be -1, right? So if x were -1, it makes g undefined. So we know in the end that -1 will not be part of the domain of this composition, because it doesn't even get you into the first function. Okay? Now, are there any x's in red that will produce real g values that do not get us into f? Well, let's ask the question, can f be made undefined? And the answer is no. I think you'd agree. The domain for f individually would just be all real numbers. So anytime you do produce a real g value, it will get you into f. Okay? So f is a function that has its doors open to everyone. Okay? And every real number is allowed into the function f. Okay? So the domain for this example would be what? All real numbers except for that x, which was -1, is not going to be allowed. Okay? Why don't we now reverse this? Using those two functions up above, okay, let's now reverse the order of f and g. Let's put g on the outside now, and f on the inside, and then try to find the domain. Okay? So that would change our diagram here. Wouldn't you agree? Let's go ahead and erase this real quickly. Okay. Now, let's go ahead and set it up. We've got the x's, and since it's written in black, let's write them in black. And those x's will be inserted into a function f in black. Okay, and now we want real f values, which will then be inserted into the second function, g in red. Okay, so we want real f values that lie in the domain for g, and then produce real g values. Okay, All right, so are there any x's in black that won't even get you into F? No, correct? Because F has its doors open to every real number, okay? So that means that there won't be any of these kinds of situations here. So the only thing that we need to worry about now is the second, where the x does produce a real f value. Okay, so it does produce a real f. And then, are there any of those f's that won't get you into G? Okay, so similar to what we did before, we need to look at what G does to its inputs. Well, G will always create a fraction where the numerator is 3. But it takes the input, whatever it might be, and it places it into the denominator and adds 1. But what is G taking in as input? The answer is F. Right? So we're talking about F values. Okay? Call it F of X to be more specific. Okay? And now, what are we worried about? We're worried about the F value becoming -1, right? Because if F in black is -1, then -1 plus 1 would then be a 0 in the bottom, in the denominator, and then G would become undefined. So that's what we need to figure out. That F in black, when it adds with that 1 in red from the G function, how can we produce a 0? Okay, so you can see that we have to solve this equation for x in black. So we end up with 3x plus 2 equals 0, and then solving that equation, x is -2/3. Okay, so read this backwards now. When x is this number here in black, okay, oops, I just lost my pen. When x is -2/3 here in black, it will produce an f value which is equal to -1, which will then make the G undefined. That's what this says. When x here in black is plugged into the f function, okay, it will then add with 1 and make our denominator for G equal to 0. Okay? So, in conclusion, what's our domain? The domain is all real numbers except for that -2/3 in black. Okay? Every other real number is in the domain of the composition. All right? Do your homework.